Hello everyone and welcome to the channel. So today I have an interesting challenge or a fun exercise for you. So we're going to think like a router and we're going to try to form an OSPF Hello packet based on the information that we have in the command output. So we're going to use the information from the command output to try and build an OSPF Hello packet. As you know, the entire operation of OSPF or other routing protocols as well is based on the packet exchange between two routers. So it's like their own language. That's how they understand each other. That's how they can speak to each other. So now let's find out what information can be communicated in the OSPF Hello packets and where we can find that information. For this demonstration, I'll be using the topology on screen here. This lab is from an unfinished project, so don't worry about the other routers right now. We'll just focus on R1 and R2. So those routers have basic OSPF configuration running, and the information is also on the screen here. So the router IDs and the subnet that they share. So I have the OSPF Hello packet structure on the notepad here. It looks like this. It's empty now, so we're gonna try to fill out this information. But there are certain sections that we're gonna leave out. For example, we're not using authentication, so these are going to be null, and the authentication data is empty or a bunch of zeros. And then here for the option fields, we're just gonna focus on these two. NSSA and external routing capability. And then a couple of other fields like packet length and checksum we can ignore for the purposes of this video. So yeah, we'll try to complete this information and then we'll open Wireshark and do a packet capture to see if we got it correct. So let me jump on R1. Let me just show you that they are neighbors, R1 and R2. There we go. Now there are a couple of commands that we can run to find this information. The most important and obvious command is show IP OSPF interface. So let's type that. Here we go. Now let's see what we can find over here. So let's jump back to Notepad and see what we got. So let's go in order. So we already have the version and message type values in here. And then packet length, we'll leave that out. Let's see, source OSPF router. So this is the router ID of the router that is originating this packet. So if we look at R1 again, let's see if we find the information here. We do, right there. This is the router ID of the local router. So let's copy that and paste it on here. Like so, and then for the area ID, we can find it here, area 0, so this is the backbone area. Actually, for the packet capture, it's gonna be displayed in the dotted decimal format, so it's gonna be 0.0.0.0, like so. And then, again, let's leave this out for the purposes of this video. Now for network mask, we need to find the subnet mask of the network segment. So let's go back to the output right here. So we can see that the IP address on the interface is 192.168.255.1/24. So let's put that information into the notepad, and it's actually going to be written in dotted decimal format as well. So it's going to be 255.255.255.0. That's a /24 mask. Next, we have the hello interval. Let's see. Right here. Hello is 10 seconds. So let's type 10 here. And now for the options field. So for this, we probably have to use another protocol. Excuse me, a command. So let's go to R1 and we can issue show IP OSPF. Let's see. So we're actually interested in this line right here. So you can see that we don't have any stub or NSSA areas. There's one normal area, and that's the backbone area that this router currently belongs to. So what that means, let's go back here. Since it's a normal area, it has external routing capability. So this bit is going to be set to 1. And these two bits are kind of mutually exclusive. So if one is set, the other one cannot be. So if you have an NSSA area, meaning that this bit would be set to 1, it does not have external routing capability, meaning that this bit would then be 0 and vice versa. Okay, for the router priority, we need to go back to the interface command. So let me do that again so we don't have to scroll back and forth. So router priority, let's see, where do we have it? Right here. Priority is 1. Okay, let's type it over here. Next we have the router dead interval. Notice here, by the way, that hello interval was way up here and dead interval down here. So this is kind of interesting. It would make sense to have them one after the other. Anyway, so that value is going to be 40. So those are default values for a broadcast network, by the way. 10 seconds for the hello timer and 40 seconds for the dead timer. Now let's see the designated router. So right here, it says the router ID of R2. But note here, the value that actually goes into this field is the interface address, which is marked right here. So let's copy that and put it right here. Paste, and then next we have backup designated router. So that information is in the line below it. So first there's the router ID, then followed by the interface IP address. So this is what we want for the packet. Like so. Now for the next part, this is not something we can directly find in the same command output. So the active neighbor field lists the router IDs of routers from which the local router has received hello packets from. That sounded a little bit complicated. Let me try to simplify that. So when R1 receives a hello packet from another router, it puts the router ID of that router into this field. So this is essentially a list of neighbors that the router has discovered. So if we go back to the command output, you can see that there is no such information here. It doesn't say active neighbor anywhere here. Actually, I have misspoken, because if you look at this line right here, it does tell you exactly that information. It says the neighbor count is 1 and that the router is adjacent with 1 neighbor, and here's the router ID. So this is actually the information we can use to put into our little OSPF packet here. There we go. Okay, our OSPF Hello packet is ready, so now we can start the Wireshark packet capture and verify that we're gonna get the same result. Actually, a note about the last 3 fields here. So when the designated router or backup designated router election is still in progress, or the designated router and backup designated router have not been elected yet, these fields are going to be 0.0.0.0 initially. And also, even before then, the active neighbor list is going to be empty because the router will not have discovered any neighbors yet. So we can actually type that into this document as well, just to keep a note of it. So initially, it's going to be 0.0.0.0, the same with the backup designated router. And then this one is going to be empty. Okay, now let me activate the packet capture on Wireshark. So let's go back to the topology. Let me enable it here on R1, for example. So we'll do capture, and we'll enable it on gig 0/0. Okay, and that should open Wireshark. And then I'm gonna restart the OSPF process on both routers. And actually, before I do that, let me just enable OSPF because that's what we're interested in. Okay, so now let's clear the process. And then let's quickly do the same on R2. Okay, so now we can go to Wireshark. Let's see what's going on here. Let's let it run for a little bit and then I can stop the packet capture. Okay, looks like they're already fully adjacent, so I'm just gonna stop the packet capture. So once we read the output, so it's not gonna keep scrolling up or anything, it's not gonna interrupt the output. So let's just double check on the routers what's going on here. Yeah, it does say from loading to full. And I can already see a problem here. So I guess I was a little too slow with restarting the OSPF process because this is showing that R2 is the backup designated router and it should actually be the designated router. We don't have to get into the details of the DR/BDR election right now, but with the default settings that we've used, R2 should be the DR and R1 should be the BDR. So this is already going to throw off our output. So you see right here, we put that R2 is the designated router and R1 is the backup designated router. Okay, let me just try to restart the packet capture and then try to be faster with restarting the OSPF process so we can get the exact output that we're expecting here. So let's do that again. Let's go back to the topology here. And let's do capture, the same interface, and this should start a new Wireshark packet capture. Yes. So we can close this one, quit without saving, and again we want OSPF. All right, so let's try this again. Yes, and then quickly. I'm still not sure I was fast enough. But let's find out. So let me go back to R1. Show IP OSPF neighbor. No. Okay. Okay, so let's do it one more time, and I'm gonna clear the process on R2 first, and then let's see if that changes the output. So, one more time. Capture on this interface and open. Okay, and again we can close this one. Let's enable OSPF. All right, so I'm gonna go to R2 first now. Clear IP OSPF process. Yes. And then this one. Okay. Now let's see what we have if we do show IP OSPF neighbor. Finally. Okay. Now R2 is the DR, as it should have been from the beginning. So let me go to Wireshark right here. Let's stop this capture. And now we can look at the output. So I mentioned that the designated router and backup designated router are going to be 0 to begin with before the election process has completed. So let's try to verify that before we look at the other values. So let's go to the packet capture. And in order to do that, we have to go to the hello packets that were sent before the database exchange. So let's scroll up a little bit here. There's a bunch of other OSPF packet types like the DBD description packets and the LS updates. So let's see here. Let's open up this entire thing. Make this a little bit smaller as well. No. All right, here we go. You don't have to worry about this part, by the way. LLS data block, just ignore that. So right here, designated router 0, backup designated router 0. And now you can see here that the router has not yet discovered any other routers. So that's why there's no active neighbor in this packet. Okay, let's look at the next hello packet. Right here. So this output should match what we have in Notepad. So let's compare them side by side. Let's do it this way. And then open this one right here, like that. Right, let's make this a little bit bigger. And then open the options fields right here. And now we should have all the information. All right, so version 2 and hello packet, this is the information we already had. We skipped packet length. Here you can see the router ID is a match. We're in the backbone area, also correct. Checksum we skipped, and again, authentication is not used for this adjacency. Then we have the net mask, which was a /24. Hello interval is 10 seconds. And here, the E bit or the external routing bit is set. Oh, I forgot to change one thing. It should say capable and not capable. So there was one tiny error. Let's see how we do with the rest of the packet. Again, you can ignore this L bit that is set, which is referring to the LLS data block. We'll leave that out for the purposes of this video. So let's move on to router priority. There's 1. Then the router dead interval, which is 40 seconds. And actually here we have something interesting. It looks like the DR/BDR election has not completed because it is showing that R1 is the designated router and the backup designated router is still 0, which means that it has not been elected. And here you can see active neighbor is R2. So let's actually try to find another hello packet where those values have been set correctly. So let's scroll down a little bit. Perhaps this one. Let's have a look. This hello packet is coming from R2 and going to R1, and you can verify that from here. This is R2's router ID, and also you can see R1 as active neighbor. So let's keep looking. Okay. How about this one then? No, looks like here is maybe where I restarted the OSPF process. Okay. Here it looks correct now. My apologies for that, for restarting the OSPF process so many times and making this a little bit confusing, but this is what we should see. Let me actually go all the way to the bottom of this packet capture where we had those hello packets once everything had stabilized and the routers were fully adjacent. So let's try this one, for example. So again, if we do a quick run through, so version 2, hello packet, source OSPF routers, router 1, backbone area, and then we left out all of these parts. Network mask is /24, 10 seconds, and external routing capability is set. Router priorities 1, dead interval is 40 seconds, and then these are set correctly now. So the designated router is R2, and this is the interface IP address of R2. And then backup designated router is R1, and this is the interface IP address of R1. Finally, active neighbor is R2. So that was the challenge or fun exercise for this video. Perhaps for the next video, I can show you how to manipulate these fields. So we could look at how to change parameters like the router ID, the area ID, the time intervals, the router priority, and so on. So anyways, hopefully this video has been fun and useful for you. Thank you for watching, and I'll see you in the next video.